Let's learn about the DREAD framework in just a few minutes. We're going to leverage Python, Visual Studio Code for this video. DREAD means damage, reproducibility, exploitability, affected users, and discoverability. Think about how you could align that to a process that exists in a piece of hardware, software, or a process. So, we have defined how we're going to create the relationships. We've given some weights to them. We have calculated them against a weight, and then we're going to save them to a list called risk values so we can use this in the future. And then we're going to run down and do the rest of this math and get just an absolutely accessible and understanding component of risk. So what we're going to do here is we're going to do Python free and then DREAD. We're going to define the damage. How much damage can happen if this occurs? Let's just say 3. How reproducible is this exploit? 0 to 10. How much work does it take to do this process again? Does it scale? No, it's kind of clunky. How exploitable is the vulnerability? How easy is it to exploit it? It's kind of hard. It's just hard to do the whole thing. How many affected users? This is important. We're going to just pick 2. We're going to keep things simple. How discoverable is this? How easy is it for somebody to find this exploit on the internet? And how much work does it take to find this vulnerability from an external observation? We're going to say it's still difficult. Name our assessment. We're just going to call this assessment. And then here we go. We've defined our damage, our reproducibility, our affected users, how discoverable it is, and the risk value. And after we've done this work, we came out with a risk value of 39. We're defining this as a high risk level, and we have actions that we can take. You know what? Let's also just give things to chance and run it. We're going to run this against a random number generator, and just imagine this as a 20-sided die. And they rolled a 2.6 after 10,000 rolls. So this situation happened to work in our favor. So here's how you can leverage science, statistics, machine learning to calculate risk without going overboard.